We're going to talk about two sections today, 5-7 and 5-8, and we're going to start with 5-7. It is called the Binomial Theorem. The objective today is to expand a binomial using what's called Pascal's triangle. That's the last name of the man who came up with this triangle that actually has pretty cool properties other than just for what we're going to use it for. And you're going to use his properties of his triangles to expand binomials. Now if we take a look, I just kind of want to talk about for a second this triangle over here. You can see that this triangle starts with a 1 at the top. Now, in order to get the next row down, you take the 1 and you travel it to the right and you travel it to the left. So you have your first triangle of, let me get a piece of paper. You have your first triangle of 1, 1, 1. Now, to get the next three numbers below it, see how this is one item, this is two items, this one will have three items? You'd bring the ones down to the left, to the left and to the right. The middle number is these two added together. So when I move my paper, you're going to see a 1, a 2, and a 1. Okay, now the next one's going to be 4 long. You're going to bring down the 1, bring down the 1, and you're going to add here to get a 3, add here to get a 3. Now if I continue, you're going to bring down a 1, bring down a 1, add to get a 4, add to get a 6, add to get a 4, and bring down the 1. See how that works? Next, you bring down your 1. The next item will be a 5. The next item will be a 10. The next item will be a 10. The next item will be a 5. And then you bring down the last one. And this would just continue on and on. In fact, what we're going to do is we're going to walk through it, okay? Make sure you understand the triangle, and then I'll teach you how it applies to a binomial. So for right now, you can ignore this, come back and review it if you want. So the Pascal's triangle starts with a 1 on the top. Then you bring down the 1s on each side. Then you bring together the 1s to make a 2, and the 1s again come down on each side. Keep this going. The 1 comes down here, the 1 comes down here. Bring these together to make a 3, these together to make a 3. And this is called Pascal's triangle, which has has a lot of details in it, a lot of which we're not going to discuss. As long as you know how to make the triangle, that's all you need for today. Bring down the 1, bring down the 1. This makes a 4, this makes a 6, this makes a 4. And then we can continue. So this would be the first row. Now, what we actually call these is this would actually be what we call row 0. All right, we call that the first row, row 0. This would actually be called row 1, okay, and so on and so forth. Okay, so right here we're at row 2, row 3, row 4, and let's continue to row 5. So you bring down the 1, okay, add to get a 5, add to get a 10, add to get a 10, add to get a 5, and then, let's see, I probably should bring that down a little further. It's actually beside it. There you go. This is row 5. Okay, row 6. You bring down the 1, you make this a 6, you make this a 15, you make this a 20, make this a 15, make this a 6, and bring down your 1. And you can see the triangle just continues and continues and continues in this pattern. That was row 6. I think on your homework you're going to have to get to like a row 8, so I'll at least get you to row 7, okay? So bring down the 1, add to get 7, add to get 21, add to get 35, add to get 35, add to get 21, add to get 7, and bring down the 1. Now I'll teach you how we're going to use this today, all right? So this was row 7. This would be a beast to FOIL, okay? In fact, I'll write it up here. If you had to FOIL this, you would have to write a plus b 6 times. One, two, three, 4. And then you'd say you have to write it 6 times, and then you would have to like FOIL these two together, get a reduced answer, these two together, get a reduced answer, these two together, get a reduced answer, these two reduced answers together, get a new reduced answer, then maybe the next two, and you'd really have a lot of math to do if you had 6 of these. That's a lot of work, and it's actually very, very, very easy to make a mistake. But Pascal's triangle can really help us. If this power is to the 6, and that's what I'm going to write, I'm going to say the power of the binomial is 6, so we use row 6 of Pascal's triangle. And this is going to actually be very easy. Now, if you want to do all that, go for it. I certainly don't. Pascal's triangle, row 6, is on the first page. We need all of these numbers, the 1, the 6, the 15, the 20, the 15, the 6, and the 1. Now, it's going to look like a lot of work, but it is actually saving you a ton of work in the long run. So, I'm going to copy those down, the coefficients. The first one was a 1. After the 1 was a 6, then a 15, then a 20, and so on and so forth. So 1, 6, 15, notice I'm spacing them out, 20, 15, 6, and 1. Those are the coefficients of row 6. And if you want to write that down so you know where you got that, we got them from row 6. Now, A is the first term, B is the second term. You are going to start with A to the highest degree possible. And then A is going to decrease as you go along. And that's the exponents of A. Now, B is the second term. You put it at the back with the highest possible degree. In this case, it was a 6. And then you work backwards. You're going to love this when it's time for calculus. You're going to love this little shortcut here. And then I don't need a B here. Technically, it would be B to the 0 power, but it's not necessary. Since all of my signs up here were positive, all of these signs are also positive. I will show you what to do when there's a negative. It gets a little more difficult. This is a very basic problem. Now we rewrite it, reducing where we can. So our final answer is A to the 6, you don't need the 1, plus 6A5B, plus 15A4B2, plus 20A3B3, plus 15A2B4, plus 6AB5, notice I left off the exponent of 1, plus B6. Notice I didn't write the implied coefficient of 1. We can do the got it together in class. Again, this starts with a very basic overview of Pascal's triangle. In problem 2, we'll go into more detail. How do you apply this if there's a coefficient of x and if there's a negative? This one will definitely be more difficult, so just understand that. Okay, first of all, that is an entire quantity, and the negative 2 is also an entire quantity. We need to be very careful with both the negative and the 3. Okay. Now I'm going to use row 5, and I will space it out as you should. Row 5 uses 1, 5, 10, 10, 5, 1. 1, space it out, 5, 10, 10, 5, 1. Because this is not just A or B, but it's 3x, when I write it, I need to write it in parentheses. Now this will be 3x to the highest possible power, 5. This will be 3x to the next highest power, 4. 3x to the next highest power, 3. 3x to the next highest power, 2. 3x to the next highest power, 1. And then we don't need to write it with an exponent of 0. Go backwards for negative 2. This will be negative 2 to the highest power possible of 5. And if you're wondering how I know the highest possible power, it's because that right there is the highest possible power, the exponent of the binomial. This is called expansion of binomials, by the way. This one here will be negative 2 to the 4th. This will be negative 2 to the 3rd. This will be negative 2 squared. This will be negative 2 to the 1st, and I don't need it for this one. Now what we have to do now is reduce each of these. 3 to the 5th is 243. If you're not sure, you do 3, 3, 3, 3, 3. 243. And it was actually 1 times, if you want to keep that just for understanding. It was 1 times. And then there's an x to the 5th power. Next, this will be more difficult. I bring down the 5. Now 3 to the 4th is 81 with an x to the 4th. 2 to the negative 1 is just a negative 2. Now I bring down the 10. 3 to the 3rd is 27 with an x cubed. Negative 2 squared is a positive 4. Bring down your 10. 3 squared is 9 with an x squared. Negative 2 to the 3rd power is negative 8, because negative times a negative times a negative. Bring down the 5. 3 to the 1st is 3 with x. 2 to the 4th is 2 times 2 times 2 times 2. It's going to end up being positive, so 16. Last, bring down your 1. Negative 2 to the 5th is a negative 32. Okay, be careful with your signs. Last thing here, 1 times 243 is 243x to the 5th. Now, let's get all this ready. If we want to do this next term, you do 5 times 81 times negative 2, negative 810. And that was an x to the 4th. Now we do the next one, 10 times 27 times a positive 4. So this will be plus 1080 x to the 3rd. Now we do the next one, 10 times 9 times negative 8 is negative 720 x squared. Now we do the next one, 5 times 3 times 16. That's a positive 240 x, and the last one will be a minus 32. So you might think that was difficult, but trust me, it's a lot easier than writing that thing 5 times and multiplying all those binomials together and reducing and combining. Okay, we'll finish the rest on another video.